Welcome back to my YouTube channel, and in today's video we are going to be dealing with implicit functions. Now, every other video that I've done before, every differentiation that I've done before this one are all explicit functions, and explicit functions are functions that are expressed in terms of x. That is, when you have y by one side, everything you are going to be seeing here are functions of x, like x squared plus 1 divided by x squared, then multiplied by everything you are going to be seeing at the other side of the equals to sign will be expressed in terms of x. That is explicit. But now when we move to implicit functions, we are going to have something like x squared plus y squared is equals to 1. Even this can actually be expressed later as explicit, but there are some particular equations whereby we can't express them at all as explicit. We have to solve them as implicit functions. For example, we have something like x squared plus 2xy plus y squared is equal to something like 5. Now, if we are told to solve something like this, probably if they tell us to solve it implicit, like they tell us to solve it using implicit functions, the way we are going to be solving it is going to be different. Now, there are some particular laws that actually govern implicit functions and some, and we are going to have to be using the ideas that we know before, like product rule, chain rule, and stuff like that, to in order to solve this kind of thing. So now, note that whenever you are differentiating an implicit function, whenever you are differentiating a function of x, is going to give you the direct derivative of it. For example, you are differentiating x squared. If y is equals to x squared and we are differentiating this, the y dx or whatever is going to give us 2x directly, which is the derivative of x squared. But if we are now looking for the derivative of something like y squared, differentiating this is going to be 2y dy dx. This is how we are going to put it there, as we are going to put the derivative multiplied by the main value, that is y dx. And a reasonable explanation for why it is like this is because when you are differentiating a function of x with respect to x, which is like x squared, as I mentioned before, if we are differentiating this, actually is going to give us 2x dx over dx. But the dx over dx is mostly left out because dx divided by everything is actually 2x times 1, which is the same thing as 2x. So that is why it's not mostly mentioned in calculus and other parts. But when it comes to differentiation of y, we have to mention that the y dx is at the back because we cannot cancel each other out. So let me try solving something like this. So now they give us this as an equation and they told us to differentiate implicitly. They told us to differentiate this. Differentiation of x squared is going to give us 2x. Then differentiating this now, we are going to bring back our idea of product rule. We cannot just differentiate this anyhow. So we have something like 2xy. Now, this can be differentiated into two parts. You can take 2x one place and y the other place. This is exactly how it's supposed to be. So we are going to be using product rule, which is something like which is v du dx times u dv, abi not times, is a plus sign, plus u dv dx. So if we are differentiating something like we pick the first one as u, the other one as v, you can pick this anyone. Let's say this is our u and this is our v. Let me write it out. U is equals to 2x. Then we have our v is equals to y. So our du dx here is equals to 2 and our dv dx is equals to 1. Remember when I said we have to put the y, the x. So now the 1 can be excluded. So it will be dy dx. dv dx is equals to dy dx. So this is how it is then. When we are applying this formula, we have it as v. Our v is y. And y du dx, which is 2. Y times 2 plus u, which is 2x. 2x times dv dx, which is dy dx. So now this right here, let me simplify it. We have 2y plus 2x dy dx. So now this here is the differentiation of this, which is 2xy. Like where we cannot differentiate, x and y are not the same functions, so we have to treat them as products of each other. Then when we treat them as products of each other, this is what we are going to get as something like this. But instead of using this long cut u and v and so, we can just instead of using the long cut at which I use, if you want to do a more faster work and a more efficient work, we pick one function like x, then use it to multiply the the derivative of y, then add it with y multiplied by the derivative of x. We will actually get the same thing. So let me say I'm leaving this 2 out plus 2 in brackets, which is the shortcut I'm talking about now. We are going to get the same answer as what we did using the normal product rule. So let us say we pick y, x. X here, we write it here, x multiplied by, what is the differentiation of y? Is 1 times dy dx. So we have it times x dy dx. Then we will add it by y, we leave it here. Then what is the differentiation of x? 1. So it will be y times 1, which is 1. Yeah. Then we add our plus 2. We have y square here again. The differentiation of y square is 2y. The y dx. Don't ever forget your dy dx. Is equals to, the differentiation of 5 is equals to 0. Every constant, the differentiation of a constant is equals to 0. So when we expand this, we have 2x plus, expanding this, we have 2x dy dx plus 2y plus 2y dy dx is equals to 0. Now you will notice that the answer at which I wrote earlier before down here is the same as both 2x dy dx plus 2y. So we are actually getting the same thing. So now this is where we stop. So from here we are going to make the ones with dy dx the subject of the formula. When making this subject of the formula, we have 2x dy dx plus 2y dy dx is equals to, when we bring this over here, we have minus 2x and minus 2y. We bring this over here, we bring this over here. So we have it this way. So after bringing them both sides, we make the y the subject of the formula on one. We bring the y out on one side. So here the y is common. We have dy dx, open our bracket, 2x plus 2y here is equals to minus 2x minus 2y. So when we bring out our dy dx, divide both sides by whatever that is the coefficient of dy dx. We have it as 2x plus 2y. Here we also have it as 2x plus 2y. This one cancel this one. We have our dy dx is equals to minus 2x minus 2y divided by 2x plus 2y. Now most of the times the answer usually end up in this way, but right here I'm seeing a loophole, like the denominator and the numerator are the same if I can bring out the minus sign out. If I'm bringing out the minus sign in this, we will have it as equals to minus open bracket 2x plus 2y. That means you can have 2x plus 2y over here and still have 2x plus 2y down here. So by the time we have to divide this and divide this, we will have our final answer as -1. But most of the times, implicit function usually end at this particular point. So that is it. So implicit function does not only work for things like this. You can also see it in trigonometry and so other. But for now, we are done with this about implicit function. You can practice questions.